Hello, my name is Ishan, and welcome to my Lava Learn. Today we'll be going through the basics of a hardware project. Now, this is not designed to be all-encompassing or anything like that, but this is designed to kind of introduce the idea of hardware and a hardware project to those of you who have never dealt with hardware and so maybe don't know where to start. Just for a little bit about myself, a bit of background so you know where I'm coming from, I was in the spring of 2020 Lava Lab cohort where I worked on Sentry, which is a security-focused smart home device. It's pretty cool. I would recommend checking it out. In terms of just my experience in doing this kind of electrical stuff, I've been a course producer for E109 and EE250 during my time here, and I've also worked in some research labs in the civil engineering department working on the electrical portions of their projects. So that just, I've also been working, I am an FRC alum, First Robotics, if any of you are into that. And I've just been working on small projects like this with Raspberry Pis and Arduinos for many years now. If you have any questions about myself, my background, or your hardware, like this tutorial, your own hardware project, anything like that, feel free to reach out. Here's some contact information here, and I'll include some in the description as well. And just to put a face to the name, here's my quote professional headshot, as well as probably a more realistic picture of who I am. But anyway, not so much about me. Let's get into, you want to do a hardware project. Let's just get into some examples. So maybe you can see kind of what you can do with a hardware project. Maybe you want to use a sensor to tell your computer how close something is. So maybe you can, I don't know, detect if a door is open or closed. Maybe you want to send wind speed to your computer so you can figure out, I don't know, how hard someone is inhaling on a joule. So maybe you can figure out how much vape smoke they're getting in their lungs. Maybe you just want a system where you can turn on an LED with a switch, like this. Okay, that wasn't that cool, and that might actually not need a computer. But the point still remains that you could use a computer. The question you might be asking, and that I'll try to answer, is how do you get your sensors, buttons, and other electronic items to interact with your computer? And I'll be honest, it's kind of hard to just connect these two things together directly. Most computers don't have the input or output required to directly interact with these pieces of hardware, but there are products that do have these abilities, and that's what we're probably primarily going to be dealing with. Primarily, I would recommend it. This guide is centered around the Raspberry Pi. If you don't know what this is at all, I've included some helpful links in the description for you to click through and learn more about the Pi and why it exists, as well as why I think it's so great. But I'll give you the short of it right now. The Raspberry Pi is a Wi-Fi capable, Bluetooth capable mini computer with relatively low cost and the ability to interact with all sorts of real-life electronic things like the sensors and buttons and all that I've mentioned before. What this means for you as a developer is that the Pi can connect to the internet or to your laptop and talk to these devices for you with a bit of programming. Today, we're going to kind of focus on getting the Pi set up so you can use in such a scenario for your hardware project. Specifically, we're going to do a small project with it where we use a button and an LED as kind of input and output devices, so you can see the basics of maybe how we interact with the Pi and how the Pi can interact with its environment. So I'll be honest, this guide that I'm providing isn't fully comprehensive. The first step I can provide for you is to obtain and set up a Raspberry Pi, but that's a topic that has already been covered excessively online. There are numerous guides on how to obtain, set up your Raspberry Pi, as well as plenty of forums for any kind of issue you could run into, which I can virtually guarantee that hundreds of other people have probably run into the same issue before, and so there are great solutions on it online. Raspberry Pi creators have their own setup guide, which I've linked in the description, and I use. It's personally absolutely great. The short of it, though, for those of you that would like it, is that you should take an SD card and burn it with an image of the Raspberry Pi's operating system. This will let the Pi boot up into a usable state that you can then configure. I would recommend doing this with some kind of screen plugged in, as well as a keyboard and mouse, although those aren't necessary, but they make your life much, much easier. I'm going to go off of the assumption that you can perform an initial setup on your own, at least to the point where the Raspberry Pi is able to boot up and show some kind of screen. Maybe something like this, where you can see a simple desktop and it telling you to perform some setup steps. Follow those setup steps, which will help you connect to the internet and do some other things. And then we can start getting into making an actual hardware project with our Raspberry Pi. Cool. So assuming that you set up your Pi now, let's make our actual project. Let's get a bit into the hardware of it so we can learn a little bit more about how all of this works. Okay, here's a very rough picture of the hardware that I'm going to be using today. I'm using a program just called Fritzing, which is why everything looks kind of low, like a very strange computer rendering. But it's going to help me model what we're doing. And that way you can kind of look at this, follow along at home with your real hardware, and it'll just be like nicer, more accurate than me taking pictures with my cell phone. So let's get started by just what are we looking at? Let's figure out what's on screen right now. So this, as hopefully you might know, is our Raspberry Pi as we've seen before. It does look a little bit different because this is just a bad 3D rendering, but it's there for representation. One thing I'd like to note about the Raspberry Pi is these pins I've just highlighted. These pins are how we're actually going to talk to our hardware. They're called GPIO pins, General Purpose Input Output, and they're designed to connect to circuits and devices so the Raspberry Pi can send and receive messages from those pieces of hardware. These are pretty important because they're what actually let us talk to the Raspberry Pi and let the Raspberry Pi talk to devices, and they're going to come back in a little bit. But I just want to highlight them right now as this is going to be our primary method of talking and dealing with the Raspberry Pi. Next up on the list is this. This is called a breadboard. It's a very common tool used for electronics prototyping, and it will serve to help us connect the Pi to our hardware. It's got a few interesting properties, which I'll just go through very quickly. First, you can see it's got a lot of holes, and these holes are for us to put wires into so we can connect things together. Because they're just holes and not any kind of physical connection like solder, you can easily take wires in and out of the breadboard and fix any mistakes you might make, rewire it if you have more parts, if you need more connections, anything like that. And breadboards are just very common and they're great for prototyping, which is what this is primarily aimed at. What you can't see, by the way, about these holes is that underneath all that plastic, there are actually more metal connections. So I've just added some lines to show kind of how these connections work. On a breadboard, these holes are connected underneath the plastic with some metal tubes. So everything along the long side on the edges of the breadboard is connected together, and everything on the short side on the inside. This is done so you can plug something into the breadboard and then easily connect multiple things to it. For example, the sides are designed to be used for power, so you can plug power lines into just one hole, like right here, and there will be power all along the holes on that side. That means that if I plug something into the breadboard, kind of like this, it will be connected. If I plug something in at that green circle, it will be connected all along that red line. If this concept doesn't make too much sense, I've included a link down below that better explains the subject. But the short of it is that it will help us make our connections and help us connect our hardware to the Raspberry Pi itself. Cool. So now let's get to the last part of this, our actual hardware pieces. On the left, we have a button, and on the right, we have an LED. In between both of those, we have resistors. We'll get into this in a second, but these aren't going to be size accurate. These are just designed to be your LED, your button may look a bit different, but this is just a general representation of how these devices look. The button is going to serve as our input device, sending messages to the Raspberry Pi of whether or not it has been clicked. The LED will then be our output device for this example, and we'll use the Raspberry Pi to make it light up or turn off based on what's happening. In between them, like I said, we have some funky looking devices called resistors. I've linked something in the description if you want to know more, but I'll give you a short explanation here of what they are and why we have them. Very often, for example, with an LED, if we just connect it to power and ground, it will work, it will light up, but it might work a bit too well. It'll be really bright. A lot of power will be flowing through the device, and that will make it heat up and so burn out more quickly. Resistors are essentially devices designed to waste power, in a sense, efficiently, lowering the amount of power going through other devices on the circuit, so that way those devices can still work, but not maybe burn themselves out as quickly. That's not entirely exactly how it works, but it's a very rough idea. If you have some questions, you should check the documentation. And what about the one that I have next to the button? Buttons are often wired to connect power directly to ground. So it's really easy to tell when they're on or off. If we're seeing ground, then they're off, and if we see power, then they're on. The issue with that, though, is that when they're on, that is when the button is pressed, power ends up directly being connected to ground. This is called a short circuit, and this can damage your hardware very badly because you're essentially just directly connecting power to you're directly connecting power to ground, which causes a lot of energy to be spent in the circuit. To avoid this, we're going to use a device to suck up that power, so that way you can indirectly connect power to ground, and that way your Raspberry Pi will be able to handle what you're doing. So we're going to add in a resistor there too to efficiently waste that energy, which is why there's one for the button. Since this is going to come up when you try to find resistors and if you try to build this yourselves, the resistor I have for the button is around 10,000 ohms, and the one for the LED is more around 220 ohms. Ohms, for reference, is just a measure of essentially how much energy the resistor is able to efficiently waste. These two devices need different amounts of power to be sucked up. The LED needs a lot less power to be sucked up than the button does. And so they are different sizes or really amounts of resistance to account for that. Okay? So now that we know what each of these items on screen are, let's get into wiring them up. We'll go step by step so we can all understand what's happening. And okay, I'm going to start by wiring up the button and the LED to the breadboard. That for me looks something like this. So you can see that we've wired them up, and they're wired up to two separate paths, and that's just so they don't mix up their signals. But there's a lot going on here. I've connected a few things already, so let's go through step by step to show what's happening. The LED looks pretty simple, so let's start with that. So I've wired up one side of the LED. This is the negative side of the LED. In your LED, you may notice that one of the pins is longer than the other. Very often, the longer one is the positive side of the LED, and the shorter one is the negative side. So this would be me wiring up that negative side. I've connected it to its resistor and then connected that resistor to the long line of pins on the breadboard by the blue side. When I said earlier that all of the things along the side are connected, that's usually used for power and ground. So everything on the red side is meant to be power, and everything on the blue side is meant to be ground. I've connected it to the blue side so we can ground out the LED. This way, when we connect the LED to the Raspberry Pi, we can provide power to turn the LED on and then remove power and it'll turn off. We will also connect this ground to the ground of the Raspberry Pi, which helps create a complete circuit, but we'll get into that a bit more later. For the button, it looks a little bit more complicated, but it's not that bad. We've connected one side of the button to power and the other side through a resistor to ground. This way, when we press the button, power will flow, and when the button is open, power will not flow. This is great. And now we have these two pieces of hardware kind of roughly wired up. How do we get them to talk to the Pi? Great, let's start wiring up the Raspberry Pi next. Okay, before we start wiring up the Raspberry Pi, let's just understand a little bit more about those pins that I was talking about earlier. Now, I've shown you the pins before, but now all you really know right now is that they exist. So here's a labeled diagram that shows what the pins are on the Pi and how we can use them to wire up our circuit. You can see that there's a lot of pins. I believe on a modern Pi there's about 40. And while some of them have specific purposes, such as, for example, the pin that's number 1 is called 3v3 power. It will output 3.3 volts of power relative to its ground. 2 and 4, for example, will do 5 volts of power relative to the ground. 6 will be the ground state. Yeah, there's a lot of pins, and some of them have specific purposes. Some of them are more, general, and they just say GPIO and a number. These GPIO pins are the ones we're going to be using to send and receive signals, because those are a general purpose input-output pins, while the others we're going to use to help complete the circuit. You can read a bit more about these later. Again, I've linked it in the description. But one thing I want to stress is that it's important to know what pin you're connected to. They all have different purposes, and so they should be used carefully, because connecting something wrong could damage the hardware. Also, just as a kind of fun aside that's going to come up in a little bit, do you see how in the first column of pins, the second row, the pin that's numbered 3 is called GPIO2? I want you to just be aware of the fact that, the pin numbers and their actual labels are entirely different. So you should be aware of which one you're working with at any given time. For example, if I wire something up to pin 3, in hardware it's on pin 3, but in software it's on pin 2, and we have to address it as such. Okay, cool though. So I'm going to keep this off to the side as we continue to wire this up, just so we can keep this reference in mind. Now, I've just added in 2 more wires. I've wired up the power and the ground of the Raspberry Pi to our breadboard. Now, when we turn on the Raspberry Pi, we're going to have power actually flowing to the circuit. So that way, everything will be kind of interconnected a little bit better. I've used pins 1 and 39 as power and ground, respectively. At this point in time, while you won't be able to see this happening, if you were to turn on the Pi, you now have at least one complete circuit in the button. If you don't press the button, the circuit will be open. If you press the button, the circuit will be closed, where power will flow from pin 1 on the Raspberry Pi through your button, through the resistor, and then back up through the ground into pin 39. So now we have at least one complete circuit. So let's try to connect the LED to the Raspberry Pi so we can control it. So that was pretty simple, right? But we've connected the LED on our Pi to pin 11 in hardware, which represents GPIO pin 17. We'll need to remember that later. But for now, if we go to the Pi and we figure out how to turn on GPIO pin 17, we'll actually be able to turn the LED on and off. And now let's connect to the button. Okay, that looks kind of strange. That circuit doesn't really make sense. I don't know what's going on here. So let's walk through it and let's explain a little bit. We just connected the button with one wire to pin 15 or GPIO pin 22, and it's connected between where the button ends and the resistor begins. So what this will do is that when the button isn't pressed, that is when the circuit is open, the pin on the Raspberry Pi will essentially, through the resistor, be connected directly to ground. And that way, the Pi will read a 0 because the pin will be connected to ground. When we press the button, then power will flow, through the button and then into the resistor and into the ground. But we are able to see what the value is of the circuit before it hits the resistor. And since the resistor is the part that burns all the power, there will be lots of power going into the resistor before that. And so our Raspberry Pi will be able to read a high signal. Again, that's not exactly how that works, but it's a very good approximation of how this will all work. This way, when the button isn't pressed, we get a 0, and when the button is pressed, we get a 1. As such, we know now that we know now how to read the button on the Raspberry Pi, so we can distinguish when the button was and wasn't pressed. And so with just those few wires, we're done with the hardware side of this very basic project. Now let's switch over to the Raspberry Pi to get it all set up for what we're doing. Hey, so now we're back, and here's the screen of my Raspberry Pi. I'm just recording it with some software so that way you guys can follow along. As we write code, you can see how the hardware changes. I'll be interspersing this footage with some from my phone of the actual hardware so you can see how, as we write the code, we'll get the hardware to do more and more things. So anyway, let's just get started by actually writing some code to interact with those GPIO pins we have. So I'm going to open up a Python 3 instance. I'm just gonna make that, I guess, a tiny bit bigger so we can, write a little bit more. But anyway, let's start writing some code to actually interact with the Pi. So by default, your Pi will come with a Python library called GPIO that lets you actually talk and interact with the GPIO pins that we were talking about earlier. So I'm gonna just import that real quick. Cool. And we have to do a little bit of setup. We have to tell it how we want to address the pins. I prefer there's two methods of addressing them. Either you can address them by the pin numbers 1 through 40 that we saw earlier, or you can use the labels. I prefer using the labels, so we're going to do that right now. I'm going to set it up for using those labels. If you don't want to do that, you can use gpio.board instead of gpio.bcm. But for the rest of this, we'll be assuming that you set it up with gpio.bcm. Cool. So if you remember the GPIO pins we had earlier, we had 17 for the LED and GPIO 22 for the button. So I want to start with the LED because that's going to give me really immediate results. I can see it turn on and off. So I'm going to set it up and that's an LED, that's an output. So I'm going to set it up 17 as an output, right? So let's do that. Wow, I really can't type today. Okay, cool. It gives me a warning. That's because I've just been doing some development with this earlier today, but yours, it probably won't give you the warning. That warning is just it saying, by the way, you have some other code running that's using this already. I'm going to ignore that because I know what the other code is. It's not going to bother with this. So cool. Now we've set up GPIO 17 as an out. And what can we do now that we've done that? We can do something like gpio.output, and we can type in 17, and we can set it to true, 1. And if I do that, you'll see on your own Raspberry Pi, if you do that, it'll turn it'll turn on. And I'm going to make a little video. Well, first let's turn it off first because it's really bright on my screen at least, or on my desk. So I'm going to set it back to false so it turns off. Cool. So now I've turned it off, turned it on, and now I've turned it off. And I'm just going to intersperse this with a little video so you can see kind of what happened as I ran that code. So right now it's off, and then I turned it on. It's very bright, and now I've turned it off again. Okay, and as I ran that code. So right now it's off, and then I turned it on. It's very bright, and now I've turned it off again. Okay. Yeah. So Cool. Now we can interact with the LED a little bit, and we can probably do some cool things with that. But let's get to interacting with the button. I want to do that. So in the same logic, let's do setup, and it's a button. We want input, so I'm going to set it to GPIO.in. Cool. And I'm going to let's try to read it right now. I'm not pressing the button, so let's see what it says. It says 0. Cool. I'm going to press down on the button and see what happens. Now it says 1. Let go, 0, press down, 1. Okay, cool. So we can get a really clean 0 or 1 to our pins depending on whether or not we press down on the button. That's great. So cool, now we have some input, now we have some output. Let's connect them together and let's do some things. So let me exit out of this. I'm going to see down on my desktop just so I can save the file, and let's write a little bit of code that'll, I don't know, hopefully, let's make it very simple. Let's make it so if we press the button, it just toggles if the LED is on or off. Okay, so how would we do that? I'm going to use Vim personally, but like let's just, let's write a little file that's going to do this code for us, right? So Vim, I'm just going to call it example.py. Cool. And let's write this. So I'm going to import that library again. I'm also going to import time, and you'll see why in a second. Time is just a library that lets us set timers and weights and things like that in code. So, okay, I'm going to define LED pin as being pin number 17 and button pin as being value number 22. And that way we can just, have easy references for what those are. Maybe later on, if we want to change what pin everything's wired up to, it won't be so hard to change our code. Okay, so let's also do some setup. So we have to set the mode of the GPIO. I'm going to use GPIO.bcm, like I said. Let's also set up those pins, GPIO.setup, LED pin. We want that as GPIO.out, and GPIO.setup. The button pin, we want that as GPIO.in. Cool, right? Let's also do something that keeps track of the light status. And initially, when I start this, I want it to be off, so I'm going to set it to false. And I'm also going to make sure that the light's false by doing GPIO.output, LED pin, light status, which right now should be false. Okay. Now let's write a while true because we're lazy, and this is just how you can do some quick debugging, some quick writing of code. If that GPIO.input from the button pin equals true, that is, if someone's actually pressing the button, let's do light status equals not light status. It'll toggle the value of that. And then GPIO.output light. On the light pin itself, we want to output the light status. Cool. I'm also going to add in just a time.sleep over here so it doesn't run too quickly. Let's just do it for 100 milliseconds. And great. Now let's write this out. Let's write a file. Let's try running it and see what happens. Python 3 example.py. So you'll see, it gives me some warnings because I'm already using those. I'm already using the things, but we'll be able to. I'm going to intersperse this with the footage now, but it's off by default. I press the button, it turns on for a second. So let's press it again. Now it's on. Now it's off, on, off. And if I hold it, it'll toggle. It'll flash very quickly. Cool. So now we have some code. Now going back to this, we have some code now that will interact with the hardware in the circuit that we've set up. And yeah, pretty easily do some input and output. So I hope that this helps reduce some of the mystery of hardware for you. Helps kind of explain what's going on, why it's going on, and all of that. And yeah, if you have any questions, please feel free to contact me. Otherwise, I hope you have a good rest of your day. Thank you for watching.